Okay, in today's video we're going to talk about the quotient rule for derivatives. The quotient rule is similar to the product rule in so much as if you can memorize the rule, it's very straightforward and easy to use. So the quotient rule is going to be if we have some function f of x that is the quotient of two other functions. In this case, we're going to call them g of x and h of x. And all the quotient rule says is f prime of x is going to be equal to h of x times g prime of x minus h prime of x times g of x. All of that over h of x squared. So we're going to listen to a calculus musical song in class, and what it's going to say is low d high minus high d low all over low squared. And when they're saying high and low, they're talking about the numerator and denominator of your fraction. So when they say low d high, low stays the same, d high means the derivative of the top, minus high d low. High g of x is the same. D low means derivative of the bottom, derivative of low, which is h prime, over low squared, which is h of x squared. Now there are two big things that we have to remember on quotient rule, and that is the order. So we have to make sure we have h of x times g prime of x and then first, and then h prime of x times g of x second. The second big thing we have to remember is that it's subtraction in the numerator. It's always subtraction. It will never be anything other than subtraction. So it's probably a good idea when you're thinking about your quotient rule to put a set of parentheses in your numerator right here. That way we know we're not going to mistakenly forget to distribute our negative when we have that little spot right there. If we don't distribute a negative, we're going to be in trouble, and we're going to miss pretty much every problem that deals with quotient rule unless we get lucky and we don't really have anything but one term there. So let's look at an example real quick. So if I say f of x is equal to, I don't know, x squared plus 3 over 4x plus 1. So the first thing I want to point out is this problem is not an STD. So if you remember when we did power rule, if this were just 4x in our denominator, we could do x squared over 4x, 3 over 4x separately and treat it as a power rule problem. But since it's 4x plus 1, that plus 1 gives us a second term, so we can't actually use the power rule. We have to use the quotient rule here. So if you think about this in terms of g and h, we could say that the g of x from our rule would have been x squared plus 3, so g prime of x would be 2x, and we could think of h of x as 4x plus 1, which means h prime of x is equal to 4, and we could just think of h of x squared as 4x plus 1 squared. Very rarely do you want to actually expand that. We almost always want to keep it as 4x plus 1 quantity squared. So if we have all the pieces right here, all we have to do is put the puzzle together and we can come up with the derivative. So we want to do low, so 4x plus 1, d high, so the derivative of the top, derivative of g prime 2x, minus, always minus, then I'm going to put in some parentheses there, high, keep the first one the same, the numerator the same, so x squared plus 3 times the derivative of the bottom, which would be 4, all over the bottom squared. And then we want to do a little bit of simplification in our numerator. So we don't really want to do anything with the denominator, but the numerator we do. So we're going to get 8x squared plus 2x minus, keep our parentheses for now, 4x squared plus 12. All of that's still going to be over our 4x plus 1 quantity squared. And now is where that negative sign right here is really important with these parentheses. That way we know to distribute our negative. So we're going to have 8x squared minus 4x squared is going to give us 4x squared plus 2x, and then minus 12 because we have to distribute the negative 1. All of that over 4x plus 1 squared. So that's your quotient rule. We will call it quits on the video.